here, the function of x, y, and z, that's phi of x, y, and z, is 3xy squared z squared. That's a scalar function. Then you have a vector function here, a equals 3xzi minus xy squared j minus 2x squared y k. So I know that phi is a scalar function because there are no directions, only magnitude. But a has the directions I, j, and k. So it has magnitude and direction. Alright, so you're supposed to find the gradient, that's the grad of phi, also the divergence of a and the curl of a. Now, I copied this thing over here from your formula sheet. I want you to pause the video, write this down, and go ahead and complete it. Okay, good. You're finished. What did we get? Let's work it out. So here, remember the grad, it works on a scalar, and you get a vector from it, right? Now remember, grad is gradient, and to get the gradient function, you differentiate. You have x, y, and z here. So you have to do some partial differentiation. Now the gradient will have a direction, alright? So that's why you get the vector there. So grad is the upside down triangle, nabla, dot nabla of phi is going to be the partial derivative of phi with respect to x in the I direction plus the partial derivative of phi with respect to y in the j direction plus partial derivative of phi with respect to z in the k direction. Alright? So you're going to need to find out what these things are. Partial phi by partial x is equal to what? It's going to be 3y squared z squared in the I direction plus partial phi by partial z is what now? 6 xy squared z in the j direction plus partial phi by partial k by partial z. No, what did I do a while ago? I said this should have been partial phi by partial y. 236 xy z squared, right, in the j direction plus z now 236 xy squared z in the k direction. Good. So there you have it. You have your gradient of phi. That was part 1. We need part 2 now to find the divergence of A, right? Now we have a vector here, A. Now the divergence of a vector is going to be the dot product of grad and the vector A. Now grad itself, is partial by partial x in the I direction plus partial by partial y in the j direction plus partial by partial z in the k direction. That itself, it cannot stand by itself. It has to work on something. The grad is waiting for you to put something there. It's like it's a sign. Question is sign of what? So if you say gradient, you say gradient of what? It's gradient of this. This thing is, what is it again? 3x zi. So it's 3x zi plus, no, it's minus xy squared j. So it's minus xy squared j minus 2x squared y k minus 2x squared y k. Alright. So the divergence is going to give you a thing there, a scalar, because of that product, right? Now remember what you do when you find the dot product of two vectors. Whatever multiplied by I in one vector multiplied that times whatever multiplied I in the other vector. So it's coefficient of I in this one times coefficient of I in that one. Plus coefficient of j in this one times coefficient of j in that one, the other one. Plus coefficient of k in this vector times coefficient of k in the other vector. Alright? So you won't have any direction. It's going to result in a scalar. So it's partial by partial x of 3xz plus partial by partial y of what? Of negative xy squared plus partial by partial z of, my writing going downhill, partial by partial z of, as it's again, negative 2x squared y. Alright, good. Now this is equal to, we differentiate this, we get 3z is going to be minus, differentiate this with respect to y, you get x. No, it's going to be 2xy. You're going to have a minus again, minus. When you differentiate with respect to z, you get 0 because x and y are constants as well as the 2. So it's going to be 0. So the divergence of A is just 3z minus 2x y. Alright? Now what else happened here? Oh, the curl. You're supposed to find the curl of A. Let's do that in the next video.